The advantage of this are quite obviously. First and foremost thing, the fourth bullet, no more reworks. Let the track record of my heat treatment shop. For the last 25 years I am running this heat treatment shop, there is no rework. That kind of a abhiman or pride, we should try to achieve that. And the last two one are basically ISO standard factors, increase customer satisfaction and assurance of high quality. Next. Yeah, this is what I was talking of. A typical on-off controller. At a particular set point, 925 degrees, you have set there, it trips off faithfully. It does. But then the initial heating in the heating power in your heating elements boosts the furnace, continues to heat it up to another 5 or 10 degrees, which is called as a hysteresis in the instrumentation language. It continues to go up. And then it starts cooling down. Natural cooling. There is no forced cooling. Natural cooling till it comes down to minus 10 of that set point, 925, minus 10, 915. Only then the contactor is on and the heating element on. So this variation of 20 degrees band, hysteresis, whatever we call it, instrumentation language, can be very, very crucial for your furnace operation. And similarly, the heating and cooling slopes, are we really ideally deciding the heating cycle program, or what we call as d theta by dt, the rate of temperature increase with reference to time. For that I have to go back to differential calculus, we will not do it now. And this process, type of temperature controller what you use, type of cycles what you use there, I mean the heating and cooling slope, and the duration. Nothing more, nothing less. This particular job requires 4 hours of carbureting. 4 hours you have to chop it and pass it on to the diffusion cycle. Next. These are all add-ons. Add-ons. You buy one pair of shoes, you get one socks free kind of thing. So this, all kinds of these instruments. And the first item, what we call as mapping, furnace temperature. You have got a thermocouple in the furnace. It is faithfully measuring the temperature. But are you sure that temperature with reference to the drop is reaching the job? Or as the job is traversing through the furnace in a typical billet heating furnace, pusher furnace or whatever it is, from the cold end to the discharge end, is the temperature growth gradual, uniform, or slowly and suddenly boosts up? It depends upon your burner location and burner capacities, and you are not interested in creating thermal shocks in your job, and you are not interested in ruining your fuel consumption. And therefore, MI thermocouples, mineral insulated thermocouples, this guy makes a lot of them. And you tie these thermocouples to the jobs and let the thermocouple travel along with the job. 30, 40, 50 meter long thermocouples, you tie to the job and let it go there, and the entire profile of the temperature in the furnace can be mapped. That's why it is called as mapping. And on-off controllers have no more relevance in the modern industry. We should go at least PID controllers, if not programmable PID controllers. I think Kalpesh would talk more about it. And finally, this relocation of burners or heating elements, which I pointed out earlier. Next. This is what I was talking of on the right side column. Heating slope d theta by dt, cooling slope minus d theta by dt. You don't want very fast heating, and you don't want, you are not quenching. You are not quenching. Quenching, the temperature drop is very, very severe. It is meant to be. That is what your aim is. And where in quenching media, whether polymer, water, oil, whatever you are using there, you don't want a gradual cooling. You want sudden, because of your metallurgical properties, what you intend upon that. And these are the areas. Now this is a fourth bullet on the left side. My furnace doesn't have a load there, so that Raj bhai ka bhi dal do, Pradeep bhai ka bhi dal do. One is 2 kg, one is 15 kg. This kind of a clubbing of the job there, which ruins the quality of your heat treatment. Next. This is what I was saying earlier. Fast heating, correct heating, slow heating. The benefit of this, fast heating, it results in excessive energy consumption. premature failing of heating elements, and possibly even warping and deformation of the jobs there. With the result, possibly you have to spend more money and time on the machining of it, so that the job is within the conformity of the customer specification. In slow heating, basically underutilization, lower productivity, increase in cost, etc. Next. And similarly, during process control, do you want to maintain the temperature within a very, very narrow limit, plus minus 1 degree, 2 degree, whatever it is, or you want to go for on-off controller with plus minus 10 degrees, 15 degrees kind of a thing there. The same kind of losses which occur there too. Next. In case of annealing furnaces, I think Altaker was talking about annealing also. Same thing. Heating slope control is very, very important. You do not want to give thermal shock to the job, nor you want to force the furnace, or you want to consume additional energy. And some of the furnaces, like typical, we have got a customer near Nagpur who does hydrogen annealing. The entire furnace is a bell-type furnace filled with hydrogen, and the job is heat treated under that for whatever duration. The criticality of hydrogen is anything beyond 15 ppm parts per million of oxygen in the bell furnace can create a hydrogen bomb. The entire furnace can go in a blast. 15 ppm is the limit. Above that is the explosive mixture, hydrogen and oxygen. You know it. Therefore, a zirconia probe is used there. The advantage of zirconia probe is you can measure it not only to ppm level, but you can measure it to ppb level, parts per billion level. That is the versatility or accuracy of it. From that level to 100% oxygen, Indian oxygen or Sanghi oxygen and so on, where they supply oxygen cylinders 99.5%, or medical oxygen, where if 2% extra oxygen means the patient takes a one-way ticket. In all these cases, it is important for you to measure the oxygen very accurately. And today in 2010, there is no known substitute to science and technology and engineering anywhere in the world than zirconia oxygen probe. And as I said, the items what you have to think of, in case the oxygen level goes up due to say leakage or infiltration, the system should be capable of giving not only an alarm but also pumping in nitrogen into the furnace so that the explosive situation is totally avoided. Safety becomes a very crucial feature in hydrogen filled annealing furnaces. Next. These are some case studies which we have compiled in rolling mill reheating furnace, where they were heating ingots. Before installing a zirconia system, their scaling was about 2.2%, it came down to 1.1%. Simultaneously, oil consumption came down from 48 to 32 liters. And in a forged reheating furnace, the scale loss came down from 4.6 to 3.0. And in case of a heat treatment furnace, bright annealing furnace, believe it or not, I am not making up a story. One of my customers, his job was to supply bright annealed bars 5 meter long, 50 mm diameter. 50 mm diameter. And because of the heavy scaling, they used to roll it to 54 millimeter. Anneal that 54 millimeter job there, and then take it to a peeling lathe to remove that 1.5 or 2 million wall thickness to give to the customer. So you can imagine what is the percentage of metal loss they were having before control. That is why the scaling loss was so high, 16.65. After installation of a proper atmospheric control system, the scaling loss came down to 0.5%. 0.5%. And in case of gas carbureting furnaces, the energy consumption dropped by about 12%, fluid consumption by about 7%, and reworking reduced to nil or almost nil. Next.